Hi class, in this recording we're going to be focusing on PhysioEx exercise 11 activity number 1. So let's dive into it. This activity is going to be focusing on hematocrit determination. We have some background information that is worth covering or worthwhile. As we're looking at this background information, we're going to be focusing on the hematocrit, which is going to be looking at how much of our blood is made of red blood cells, or the percentage of blood that's made of red blood cells. Our hematocrit is also going to look at a buffy coat, which is going to be made of primarily white blood cells, and is also going to give us an idea of how much plasma or liquid we have in our blood. I won't bother reading all of this out loud for you though. As we're working through our activity, I also need to emphasize that our red blood cells, or erythrocytes, carry hemoglobin. Hemoglobin is a pigment made of 4 globin subunits. Each globular subunit has a heme, and that heme is going to bind to an oxygen, an O2 molecule. It can carry oxygen. And there are different kinds of anemia where we don't have the ability to transport enough oxygen within our bloodstream. We can have anemias related to not having enough iron. We can have anemias related to not make enough blood. We can have anemia related to misshapen blood. So as you're working through this, make sure you read through these background information, introductory pieces of our PhysioEx activity. I'm going to go ahead and skip through these questions. You can do them on your own, and let's look at these questions. List the hematocrits for a healthy male, healthy female living in Boston sea level. Indicate whether they are normal or whether they indicate anemia or polycythemia. So as we're looking at sample number 1 is a healthy male, and their hematocrit, that individual's hematocrit was 48. So healthy male in Boston was 48 millimeters. And then healthy male and healthy female. Healthy female in Boston was 44. Millimeters. And then indicate whether they are normal or whether they have indicated anemia or polycythemia. They are both normal. Next, describe the difference between hematocrits for the male and female living in Boston. Why does this difference between the biological sexes exist? Well, the difference between the biological sexes primarily has to do with testosterone. Males, generally speaking, have more testosterone in their bloodstream than females. Elevated testosterone in the male bloodstream is going to cause the male to have more skeletal muscle mass, higher bone density, and it's also going to cause the male to have a slightly higher percentage of red blood cells in their blood. There's another factor though, and that is that females, the adult females that are premenopausal, so they haven't reached menopause yet, will menstruate, and every month they lose a little bit of red blood cells. So when you look at the fact that males have higher testosterone levels and that females bleed a little bit every month, it makes sense that males would have a slightly higher hematocrit than females. Number 3, list the hematocrit for a healthy female and male and female living in Denver and indicate whether they're normal or have anemia or polycythemia. So when we look at the male and female living in Denver, that's their 3 and 4. The male at sea level is 48. The male at Denver is 55. Female at sea level is 44. Female in Denver is 55. So those individuals, because those males and females have elevated hematocrits relative to the healthy individuals living at sea level, they have polycythemia as opposed to anemia. Next question. How do the hematocrit levels in the Denver residents differ from those of the Boston residents? Why? How well did the results compare to your prediction? So the Denver individuals had higher hematocrits than the Boston individuals. Why do people living in higher elevations have a higher hematocrit? Individuals at higher locations are exposed to lower atmospheric oxygen. Those individuals that are exposed to lower atmospheric oxygen are going to have compensate for the lower amount of oxygen in the atmosphere by upregulating the amount of red blood cells in their bloodstream so they can transport more oxygen in their blood. Next, describe how the kidneys respond to chronic disease in oxygen, or excuse me, chronic decrease in oxygen and what this effect has on the hematocrit levels. If the kidneys are exposed to a chronic decrease in oxygen, kidneys release more erythropoietin, or EPO. Erythropoietin is a hormone which travels through the bloodstream to the red bone marrow and causes the red bone marrow to have erythropoiesis stimulated, or the production of red blood cells upregulated. Question number 6. List the hematocrit for a male with aplastic anemia and indicate whether this is normal or abnormal. Well, I'm pretty sure it's going to be abnormal. Let's take a look. The healthy male in Boston had a hematocrit of 48. The male with aplastic anemia had a hematocrit of 19. So when we look at these results, obviously 48 versus 19 is very different. So this individual, sample number 5, this gentleman, clearly is going to have a lower hematocrit. But when we think of aplastic anemia, this individual with aplastic anemia has an anemia that's related to not making enough red blood cells. So you'd expect the amount of red blood cells in the individual's blood to be dramatically lower, which is what we see with our hematocrit. And then question number 7, use the hematocrit for a female with iron deficiency anemia and indicate whether it's normal or abnormal. Well, since this individual has a disease state, we're going to expect it to be abnormal. Let's go ahead and take a look at the results. So we have our baseline, healthy female in Boston with a hematocrit of 44, and then female with iron deficient anemia with a hematocrit of 32. So clearly something's going on here that's significantly lower. It's lower by about 12 millimeters. If somebody has iron deficient anemia, they have the ability to make red blood cells. They just don't have the ability to fill those red blood cells with hemoglobin efficiently. So when we look at these individuals, somebody that has an iron deficient anemia will have a moderately lower hematocrit. Somebody with an aplastic anemia should have an incredibly low hematocrit, like this individual from sample number 5 that had a hematocrit of 19. And that's all we have for exercise number 11, activity number 1. If you have any questions or comments, please feel free to post them on the discussion board. And as always, happy studies.